So you've got data scattered across various external systems, APIs, databases, file stores, and you're thinking, how do I bring all this data into my NATS ecosystem? Well, you've come to the right spot. Welcome to another episode in our Connector series where we're diving into Inlets, your data ingestion powerhouse for feeding NATS streams. In this tutorial, we're going to break down what inlets are all about, walk through how they operate under the hood, and get our hands dirty with some practical demos that'll turn you into a data ingestion wizard. Here's our roadmap. We'll kick things off by building an inlet from Amazon S3 to pull in stored files. Next, we'll configure a MongoDB inlet to capture real-time database events. And to wrap things up, we'll set up a webhook with ngrok to receive live data from third-party services. No worries if connectors are new territory for you. We're building everything step by step with straightforward examples that actually work. Ready to transform your scattered data sources into unified NAT streams? Let's dive in. When you need to get messages from external systems into NATS, you can create a type of connector that we call an inlet. Let's walk through how inlets work at a high level. When you create an inlet, it runs within a lightweight runtime environment that manages the data pipeline. Within this runtime exist two key components, a source and a producer. The source seamlessly integrates with your external systems, reading data from databases, webhooks, message queues, or any other data source you need to connect. Imagine your external systems generating data continuously, whether that's user events from a web application, sensor readings from IoT devices, or records from a database. The source monitors whatever external system you specify, pulling in data according to the configuration you defined. Once it captures the relevant data, the producer comes into play. The producer component handles the formatting and delivery of messages into your NATS infrastructure, whether that's NATS Core or Jetstream. It publishes messages to whatever stream you specify, getting the data into your NATS system. So putting it all together, the runtime runs your source and producer, which makes up the inlet connector. We provide many different sources out of the box. Now when your external system generates new data, the messages will flow seamlessly through the source to the producer and into your NATS subjects, ready for the rest of your system to consume. Before we dive into creating inlets, we'll need some data in our external systems to work with. The good news, we've already set this up in our previous outlets video, so we can leverage that existing work. You might remember from the outlets video that we built a program that publishes temperature data every 5 seconds. We're going to use that same setup to populate our external systems with data, then create inlets to pull that data back out and stream it into NATS on different subjects. This approach lets us see the complete data flow cycle in action. I'll start the program to get the data flowing in. Before we can create our inlets, we'll need to set up the streams that they'll be using. To keep things organized, I'm going to create two separate streams, one Amazon S3 and one for MongoDB. The subjects for our streams will be based on their data sources, Amazon S3.inlet and MongoDB.inlet. For our HTTP inlet, we're going to use NATS Core just to change things up a bit. We'll subscribe to the subject directly in our terminal to watch the data pour in. As you can see, I've now my two streams, so we're ready to move on to the next step, creating our inlets themselves. Let's say you have a data processing system that needs to handle batch files. When new data files are uploaded to your S3 storage, you want to process them automatically. You can set up an S3 inlet connector to monitor your bucket and pull those files directly into your processing pipeline. Now when new files arrive in S3, the connector automatically detects them and streams the data into your system, giving your team seamless batch processing without manual intervention. Let me show you how to set this up. To create our Amazon S3 inlet, we'll use the same bucket from our outlets video. We already have data flowing in, and now we want to set up a trigger system so that when the new files arrive in the bucket, we can automatically detect and process them. To do this, we need to create an SQS queue, which is AWS's message queuing service that acts as a reliable message broker. We'll configure our S3 bucket to send event notifications to this SQS queue whenever new files arrive, and our inlet will connect to the SQS queue to receive those notifications. Now that we understand the flow, let's go ahead and create our SQS queue. Navigate to the queue dashboard and click Create. Give your queue a descriptive name, and then scroll down to locate the access policy section. The access policy is the critical component here. We'll configure this using a JSON formatted policy with two key statements. The first statement grants the account owner complete administrative control over the queue. The second statement specifically authorizes S3 to send messages to this queue, but restricts that access to only our designated bucket. Once we've configured our access policy, we can proceed to create the queue. Now that we have our queue set up, we need to configure the S3 bucket to use this queue whenever it receives a new item. Let's navigate back to our bucket and access the Properties section to create a new event notification. Scroll down and find the Event Notifications section. So what we'll do here is give our event notification a name. We'll add a suffix and specify to only notify on .txt files. Then we're going to want to check the S3 object created event type. And our destination will be our SQS queue. Then we can click Save and we're all set up. So let's get a quick recap. When our inlet receives an SQS message, it extracts the S3 object information and downloads the actual file from our bucket. Our inlet then processes the file content by reading and parsing the data, whether it's JSON, CSV, binary, or other formats based on your specific use case. Finally, the inlet publishes these formatted messages to the appropriate NAT subjects, completing the data flow pipeline. And now, we can go make our inlet. Hip hip! Back on the Synadia platform dashboard, let's go create our connector. Remember, for inlets, we want to find an Amazon S3 source, so we filter for sources. Select Amazon S3 and let's push on. Now we select our bucket and our region, and then we'll need to grab our credentials from Amazon. If you've watched the previous outlets video, you'll know each connector will come with a lot of optional fields. We're going to ignore most of these for now, since we don't need them. We'll go over a lot of them in future videos for more advanced connectors. Now we need to select our scanner. This is how we'll interpret the data format of our files. Since we're working with .txt files, we'll select lines. The line scanner reads each line of your .txt file as a separate record or message. This is perfect for text files where each line represents a distinct piece of data, like log entries, data records, or any line-based content. Our custom delimiter will be new lines. This differentiates the messages. Though in our instance, each message will only be one line, our temperature data. Now we add our SQS URL. Our connector will use this URL to receive the new items from the queue. The SQS queue contains messages with the key path and bucket path for each new file that gets uploaded. When our connector pulls this queue, it gets the exact location of new files so it can process them automatically. Now we select Jetstream and our stream subject for the inlet and select our user. We'll give it a good name and description and let's go. Back on our dashboard, we can click Quick Start to start the connector. We can also click into the connector to find some details and logging and monitoring. If you watched our outlets video, you might already be familiar with this, but there's a good amount of details on the connector and you can check for metrics and errors here. Let's start the publisher and watch for messages. Our messages will flow out into S3 and should begin to flow back into our inlet subject. Let's watch. Look at that. There we go. Let's pause it and check one of our messages. Yeah, that looks like temperature data to me. We made our first inlet. Let's say you have an application storing operational data in MongoDB. When records are created, updated, or deleted, you want to sync those changes to other systems in real time. You can set up a MongoDB Inlet Connector to watch for database changes and stream those updates directly into your data pipeline. Now when data changes occur, the connector automatically captures those modifications and forwards them to downstream systems, giving your organization real-time data synchronization across all platforms. Here's how we build this pipeline. Now to create our MongoDB inlet, it's a lot less work. MongoDB has internal change streams that monitor your collections in real time by reading from MongoDB's internal oplog. instantly notifying your application when documents change without needing to pull the database. This enables reactive applications that can immediately respond to data modifications for use cases like cache invalidation, live dashboards, and real-time synchronization. All we need to do is grab our connection URL like we did in the outlets video. So click Connect. Now we're using the driver and we need to go to our connection string. Keep track of this connection string. Remember, you'll have to add your password to your connection string. Now let's go back to the Synadia dashboard to create our inlet. Back on the Synadia platform dashboard, we'll create another connector. Let's filter on sources and find MongoDB change stream. Select it and let's move on. Now we just add our connection string and choose our database and collection. If you recall, our database was sample and our collection was doc. We'll select Jetstream again and choose our MongoDB Inlet subject. We'll pick our user and then click Next. And then we just have to name it and give it a good description. Then click Save. Now back on the dashboard, I've already started the connector. Let's go to our inlet stream and wait for some messages to flow in. There we go. Easy peasy. Now if we check one of these messages, we'll notice there's some extra data in there. This comes from MongoDB. We'll see we have our document, which is our temperature data. If we want to clean this data up, we can use a transformer. The good news is, we'll be going over transformers in the next video. We're sending messages to our MongoDB outlet and now getting them back in our MongoDB inlet and into our stream. Nice work. Now let's say you have a system that needs to receive data from external APIs or webhook notifications. When events occur in third-party services, you want to capture and process that data immediately. You can set up an HTTP inlet connector to receive those incoming requests directly into your processing pipeline. Now when external events arrive, the connector automatically captures the data and routes it to your processing system, giving your team real-time integration with external services and immediate event processing. Let's walk through the configuration. All right, last but not least, let's create our HTTP inlet. This one is actually quite simple. First, I need to start my server in ngrok. If you watched the previous outlets video, you'll know that ngrok makes my server endpoints accessible from anywhere on the internet. The server has one GET endpoint that is ready to respond with temperature data. ngrok gives me this generated URL where I can access my endpoint. This is what we'll use for our connector when we create it. It will also have an inspect URL that I can use to watch all the traffic that flows to my server. With my server created and ready, let's create our connector. On the Synadia platform dashboard, let's go create our connector. Again, you've seen most of this before. We want a source because we're creating an inlet and we want to select HTTP. Next, we need to copy our ngrok URL and endpoint. We're using a GET endpoint. We're going to skip over most of these optional fields. Some of them have to do with credentials, and others handling message flow. Next, we're going to play around and select NATS core this time. We'll select our HTTP inlet subject and user and click Next. Now again, give it a good name and description, and we're good to go. Before we start our connector, let's initiate a subscription to our http.inlet subject in NATS core. Back on the dashboard, let's start our connector. After we see it start, we can go check both our ngrok inspect page as well as our subscription to our NATS core subject. If we check our ngrok inspect page, we can see requests start to pour in from our inlet. We can check each request to see the headers and the response, which is temperature data. Let's go check our subscription in our terminal. Oh wow, we can see the messages flowing in. You can check a message here and tell it's our temperature data by the way it is. Hey, that's pretty neat. Maybe some of you got that reference, but we made our HTTP inlet, huzzah! And there you have it, your introduction to inlets complete. We've shown you how to stream data from S3 buckets, tap into MongoDB change streams, and capture webhook payloads, all feeding directly into your NAT's infrastructure. What makes Inlets so valuable is they handle the connection mechanics and ingestion logistics, so you can focus on processing your data instead of building custom integration code. Next up in our connector series, we're tackling transformers, the data processing component that lets you transform, enrich, and manipulate your messages as they flow through NATs. We're talking JSON parsing, field mapping, data aggregation, and complex message transformations. You'll find all the sample configs and setup scripts from today's demos in the description. Download them and start connecting your own data sources immediately. Found this valuable? Hit that like button and subscribe for more NATS tutorials. And if you create something interesting with Inlets, share your experience in the comments below. Thanks for tuning in and keep those data streams flowing.